Hello, discrete math fans. Let's talk about the inverse of a relation. We haven't discussed this in the past. We'll make a definition like this. Say, start with a relation R from A to B, and the inverse relation from B to A, well, all we do is whenever x comma y is in R, then we'll put y comma x in R inverse. We're just swapping the coordinates in all the ordered pairs. Well, let's run through an example. Let's say A is the set containing 2, 3, 4. B is the set containing 3, 4, 6, 8. And we'll define a relation R from A to B by saying that M is related to N if and only if M divides N. And then what we want to know is what is R inverse. All right, so first we'll write down R. So what we're doing is we're writing down all the ordered pairs where the first coordinate divides the second coordinate. Then if we want to create R inverse, all we have to do is just swap the components in each ordered pair. That's it. That's what creates R inverse. If you're going to make an arrow diagram, you're just switching the directions of all the arrows because you're swapping the domain and the codomain. Let's try another one. We'll define a relation S from the reals to the reals by saying that x comma y is an element of S if and only if y is equal to x squared plus 1. Let's ask two questions here. Is S a function? Is S inverse a function? All right, well, S is a function because for each x in the reals, there's exactly one y in the reals such that x comma y is an S. You get that y through this formula. However, S inverse is not a function, and it's not a function for a couple of reasons. First, we see that 1 comma 2 is an S and negative 1 comma 2 is an S. Well, that tells us what's an S inverse, 2 comma 1 and 2 comma negative 1. That alone tells us that S inverse is not a function. You're not allowed to have two elements in your relation that have the same first coordinate but different second coordinates if you want that relation to be a function. The other reason that S inverse is not a function is because there's no value of x in the real numbers such that 0 comma x is an S inverse. You should see if you can find such a value of x. You'll discover pretty quickly that you cannot find such a value of x. Okay, that's all for now.